Welcome to the Arithmetic Zone and welcome back to our Simple Java series. Today we're going to look into some classes. So what are classes anyway? Well, Java is pretty much built by classes and built on classes. So let's look into our code right here that we made in the last video. So I made a class right here and I called it starter. A class essentially has its own variables, its own methods. Now right now the starter class only has a single method, which is the main method, as I outlined right here. And whatever is inside of the main method is what gets run every time you try to run the whole program. So if I save and run the program, I see all of my hello world text using the escape sequences that I did in the last video. So clearly you're able to make your own classes like I just did, but Java also has a lot of its own default classes, and that's what we're going to look into today. So I'm actually going to clear all this, and one of these classes that we're going to look into today, and it's probably the most important class in all of Java, is the string class. So I talked about strings earlier, but essentially a string is a value that represents any character, whether it be a number, letter, symbol, basically anything. So to make a variable of the string class, all I have to do is say string and then my name. So let's say str1, then equals, and then I put in quotes the string. So let's say hello world, which is pretty typical. And don't forget the semicolon. So I can print out this object that I made with the string class. str1 is an object of the string class, and I can make another object of the string class if I wanted to. So let's say string str2 is equal to goodbye. And I can print out these strings just like how I was able to print out integers and doubles and also booleans. So I'm just gonna put in those two objects, and if I were to run the code now, we see hello world and then goodbye right underneath it. So basic stuff. Strings are a special type of class. Usually when you're trying to make an object of a class and you're trying to declare it, what you usually have to do is after on the right side, when you initialize these variables, you have to say new and then the object, the class name, so string, and then put in parentheses your value. So right here, hello world. So this is how you would usually initialize values in Java for strings. But you don't have to do it for strings, because strings are so commonly used that Java just allows you to just forego the whole new and then the string part and then just put in the value. So I can run this and it runs the exact same. But if we have any other class, then we're gonna have to use the new method, and we already saw that when we were dealing with the scanner class. And yes, scanner is a class because I say scanner and then my object name, usually scan, and then I say new scanner, so I say new and then the class name, and then inside the parentheses I put in the value of system.in. This is how you would usually declare and initialize an object for a class. But as I said, strings are a bit of a special case. Strings are also special in that strings are immutable, which means that strings never change. What does that mean? Well, let's say instead of setting str2 to its own value, let's say str2 is equal to str1. So basically str2 refers to the same thing as str1. So if I were to print this out, it would print out hello world twice. Makes sense. But what if I go and make str1 equal to a new value, goodbye? What if I do that? What do you think is going to happen? Well, you see, str1 is going to print out goodbye, but str2 still prints out hello world. And usually when you deal with classes, any class other than string, if you were to set the value of one object to another object and change either of the objects, then it also changes the other object. But because strings never change, in that if you were to change strings like this, what it essentially does is just make a whole new string. The other object that's linked to string is never changed. This might be a little confusing right now, but we're going to see more examples of this later on. What I really want to get into today, though, are the different string methods. So classes are different from primitive values. One way in that is because they have their own methods associated with them. So let's go back to how it was before. And before I print them out, let's introduce some of the methods. So the first method we're going to go over is the .length method. So str.length. We saw this in JavaScript as well, but .length is a method for a string. So that means you're going to need the parentheses after the word length. What do you think is going to happen if I were to print out the length properties of str1 and str2? Instead of printing out the text, it's going to print out these numbers. And what these numbers mean is that it just refers to how long the string is. So this means that this is 11 characters long and this is 7 characters long. str1 is 11 characters long. And let's count that. 1, 2, 3, 4, 5, 6. Yes, the space counts. 7, 8, 9, 10, 11. So we got 11. And then if I were to count the characters in goodbye, 1, 2, 3, 4, 5, 6, 7. 7 characters. So that makes sense. So essentially .length returns an integer value that represents how long the string is. That one's pretty easy to understand. Next, we're going to look into the equals method. So I'm going to make this equal to hello world. And I'm also going to just temporarily get rid of that. So str1.equals. And .equals needs another string object inside of the parentheses for the parameter. So we're going to use str2. What do you think this is going to do? Prints out true. So .equals essentially whatever object you use it on. So I use it on string object str1. It compares it to str2. And by comparing it, it's looking to see if they have the exact same string. So these are both equal to hello world. That's why it's going to print out true. Now if I make this lowercase like that, it's going to print false, even though it's, technically the same characters. This one's lowercase, this H is lowercase, this H is uppercase. So that one little difference makes the two strings not equal. That's why it returns false. So this returns a boolean, while the .length method returns an int. Now there is another equals method. It's called equalsIgnoreCase, and as the name implies, this one doesn't care about the case of the letters. They can be uppercase, lowercase, anything, but as long as the letters, symbols, and numbers match, then it's going to print out true, as you just saw. The next method that I'm going to go over is the substring method, and this one's a little more complicated. So there's actually two substring methods, one with one parameter, which is right here, just one int parameter, and another with two int parameters separated by a comma. Don't worry about this begin index and end index. That's just a Visual Studio Code thing where it just tells you what the parameters mean. But let's print this out and try to decipher this. The first one prints out hello world without the H. So let's look into this. What the substring method does with the single parameter is that whatever number you pass in, that is the index that it starts the string in, and then it continues for the rest of the string. So I said 1. So like JavaScript, the indices start at 0. So when we're referring to specific characters in these strings, this letter H is index 0, this E is index 1, L is this first L is index 2, and so on. So when I say 1, that refers to index 1, which is the E. So it's going to basically print out everything starting from the E without this H. Now the second substring method works the same, but now there's an end index 3. So it's going to print up to including the start index of E, up to but not including the end index. So the end index is 3, so 0, 1, 2, 3 refers to this second L right here. So the second print statement is not going to print out the second L, it's only going to print out EL. And if I were to make this longer, like let's say 1, 6, and then run the code, now it prints out LO. So let's see where that, let's see why prints that out. So index 1, 2, 3, 4, 5. It also prints out the space, but it doesn't print out index 6. Remember, the end index is exclusive while the begin index is inclusive. And what's nice about, Java is that, we can combine some of these methods, inside of each other. So let's say that in the end index, instead of giving it a definite number, let's say str2.length and then -1. So what is that going to do? Prints out hello world without the last letter, because str2.length returns the length of the string, and then we're subtracting it by 1. So now it refers to the last index character, but it doesn't include that last index character when we're passing in the end index. So it's going to print out everything, including the begin index, which is 1, up to but excluding the last index right here. And this is useful when we have to change the value of str2 or str1. We don't have to keep changing the numbers. We can just use this formula if we want to get everything excluding the last character. Next, we have the str1.toUpperCase, and then we also have a toLowerCase method. And I think it's pretty clear what these do. So let's run the code. Prints out str1, hello world, in all caps. That's what the toUpperCase method does. And then the toLowerCase method, it's going to print out str2, but all the characters are in lowercase. So this one has no parameters, pretty self-explanatory, and pretty easy to use. Now let's get into a method that's not so simple. It's the compareTo method. Now the parameter is simple enough. It just takes in another string object, similar to the .equals method. And honestly, its functionality is also similar, where it just takes two string objects and it compares them a certain way. But unlike the .equals method, which just sees that if the two strings have the same value, the compareTo method is going to compare the alphabetical order of the two strings. So let's print them out. So we have 1 and -1. Now let's look into what our values are. We have hello world and goodbye. For the first one, where we're comparing str1 to str2, it's taking str1, which starts with a capital H. It's comparing it to str2, which starts with a capital G. And the G comes one letter, or rather the str1 comes one letter after str2, because H comes one letter after G. That's how it's comparing it. So hence this is going to return +1. If we were to do it the other way around, str2 compared to str1, well, str2, the G comes one letter before str1's H. So this one's going to return a -1. Now let's change one of these string values. So we could utilize this alphabet system right here more effectively. So let's say instead of goodbye, we have pleased to meet you. Save, and now let's see what letters our numbers we have. Now we have -8 and 8. Well, let's look at H and then our new first letter P. So for the first one, str1 compared to str2, where we have a -8, starting from this P, the H comes 1, 2, 3, 4, 5, 6, 7, 8 letters before P. That's why this returns -8. And the opposite version, str2 compared to str1, is going to return +8, because P comes 8 letters after H. And what if we have, nearly the same string, but one letter's off? So Alright, so this should do it. Hello world with an E in the end. It doesn't really make sense, but it's going to get the job done. It's going to return -1 and 1 because what Java does is it's just going to keep, if the first letter is the same, it's just going to go on to the next letter, compare those two. And it's going to keep comparing them until it finally gets to a character where they're not the same, and it's going to compare those. So D comes before E, hence it returns -1, then 1. If I were to change this O to a P, the first letter it's going to counter is going to be the P. It's going to return the same thing. So let me instead change it to another L. Alright, that's a better example. So the first letter it's going to counter, the unique letter it's going to counter is this L, which corresponds with this O. And this L comes before the O, 3 letters before, hence it returns +3, then -3. So definitely a confusing method to use and a confusing method to wrap your head around, especially when you compare uppercase characters to lowercase ones. So we have hello world, and then this one lowercase hello world, and now it prints out -32 and 32, because what ends up happening is that Java puts all these characters on its own set order to determine the alphabetical order. So what Java ends up doing is it puts the uppercase letters first and then the lowercase letters right after that. So it would look something like this. So if you were to look at the lowercase h, which is right here, this comes 32 characters after the uppercase h, after the 26 uppercase letters, and then the 26 lowercase letters. So yeah, definitely a difficult method to incorporate, and I'm not really going to use it too much in this series, so you can thank me for that. Finally, we're going to conclude our deep look into string methods with the indexOf method, and this one I don't think is as hard to understand as compareTo, but this one is pretty versatile in what it returns and its rules. So let's take a look. So let's run our code as usual. Alright, so let's look into the first statement. So str1.indexOf string H. So what indexOf does is that it returns the index of the first instance of the specified string that it sees in the object. So I specified H in my parameter for str1, so it's going to look for the first instance of H in str1, and it's going to return the index. So if we look in str1, first letter immediately, index 0 is H, so it's going to return the number 0 because that's its index. str2, now index of lowercase o, so look into the goodbye string. Well, it's not the first index, but it is the second index, which is index number 1. So this is the first instance of lowercase o. It's going to return the number 1. Back into the first string, str1, if I search for the letter E, that is index number 1, hence it returns number 1. And the nice thing about indexOf is that it's not just limited to one character. You can actually search for basically any string you want. It's just the first instance. So in str1, I'm searching for the string LLO, and I'm searching it, right? So index 0, index 1, index 2. It found LLO and index 2 with the first L representing index 2, hence it returns the number 2. And then finally, in this statement right here, we're trying to find the letter Z, but Z does not exist. And anytime it tries to find a string that does not exist in the object, it returns -1, because indices can only be starting from 0 up to the length of the string or the array or whatever we're trying to count. -1 as an index number doesn't make sense. Hence, that's why it just returns -1 if something doesn't exist, just to tell you that, hey, this is not in my string. If it returned 0 or a positive number, then that means that that character or string is in the string object. So that's a basic overview of string objects. What I'd like to do now is look into some of the bounds when using these string methods. So first thing you should realize is that if you declare a string object and you never initialize it to any value, so let's say I declare str2 as such, but I never initialize it, just like that, we get this red squiggly line. And if we were to try to run our code, we get an error. And you can't use a method on any object of any class that does not have, a value associated with it. So we allocated memory space for str2, but we never really did anything with it. So how can we use a method? How can we even search for the index of the letter O in a string that basically doesn't exist? It's similar to null objects. So if I set str2 equal to null, which is a special value in JavaScript, null basically means that, it just doesn't exist. So if I were to run this code, continue, we get an error, a different kind of error, but we get a no pointer exception. It prints out the 0 from right here, and then it stops working once it gets here. So this is a runtime error, where the error comes when we're actually running the code and not when we're compiling the code to see if everything works. That's because nothing here is technically wrong. It's just that when you're trying to use a method on a null value, you're going to get this error, because like if using a method for a value that doesn't exist, you can't use a method on a value that's null, because, well, there really is no value there. So just keep in mind, when you're creating your objects, make sure you actually set them to values. You could do it like this, and then what you could do is set it in a separate line, set it to the corresponding value like that. This would work out identically to what we had before. And as always, writing out strings and initializing it like this is kind of useless. You could just do the shortcut with just putting in the string value, because again, strings are a common class that you're going to be using all the time in Java, which is why we don't have to import string. We don't have to allocate memory space manually using the keyword new. But when we're going to be dealing with other classes, as you'll see in the future, we are going to be having to use that new keyword. So that's going to be it for today's video. I wanted to cover a little more, but I think strings are a major concept in Java, and definitely something that's going to take a while to get used to. In the next video, we're going to look into other classes, specifically wrapper classes and the math class. So that's going to be interesting. So I hope you guys stay tuned, and I'll see you guys then.